Hello again. I want to talk today about accuracy, precision, random error, and systematic error, four closely related terms. We usually, in kind of everyday language, we use these two as synonyms, but they are not synonyms in a technical sense. They are not synonyms in a technical sense. They have two distinct meanings, and those are accuracy is defined as nearness to the true value of a measurement. So for example, if we're measuring the length of maybe some kind of beetle or something like that, we would be measuring, to say that it's accurate is to assume that there is some true length of that beetle, and to say that we're making an accurate measurement is to say that our measurement is very close to that, or it's near that true value. Now in reality we never really know the true value, so what we might do to kind of judge this in place of knowing the true value is we might use some kind of corroborating measurement. So maybe we have somebody else measure it, or maybe we determine its length in some other manner by some other method. Okay, so there might be some other way to verify it. So we might try to verify the length. The other way to do it, so we can try to verify independently. Or secondly, we might compare to some published value. Compare to some published value. Just for example, on this first one too, I should throw out another example. The volume of water, for example, can be determined two ways. One is by measuring its volume directly using some type of volumetric device like a graduated cylinder. The second way is to weigh the water and then convert it to volume using the density of the water. So we might try something like that to verify our values. The second term, precision, means something different. Precision is nearness of the data points to each other. Nearness of the data points to each other. So this is another way of stating this, is that it is reproducibility. So how close are your data points together if they're replications? So let's say you're replicating your data and you're getting all your data of those masses. Say you're taking the mass of a single object and you're repeating that process. How close are those data to each other? That's precision. Now I want to use kind of a classic illustration here of these concepts, and that is we'll look at four targets. We'll call these A, B, C, and D. And somebody's shooting at these targets. Oops. Somebody's shooting at these targets, and here are the results. Actually, there's four different people, and so there's four competitors here, and they're all shooting at the targets. The first one shoots 6 times and gets this. The second one gets this. The third one something like this. I think I put an extra shot on there. And the fourth one something like this. Alright? And we asked the question, what can we say about the accuracy and precision of each of these shooters? This one is very precise because all of the shots are clustered together in a small group. So this person has a consistent technique. They are nailing the same spot pretty much every time. All right? But they are not very accurate. So precise but not accurate, because they are not close to the bullseye with any of those shots. So precise but not accurate. In B, we're going to say that they are not precise. However, I'm going to say that they're actually more accurate. Now, and that's because all of the shots most of these shots are closer to the bullseye than shooter A. So, and if you kind of took the average position of these shots, you'd probably get something somewhere around the bullseye if you kind of average the positions of all those shots. So this one is not precise, but it is more accurate. And on C, we have this person is neither accurate or precise. And then shooter D is both accurate and precise. Now, which would you rather be? Of course, your first choice would probably be D, both accurate and precise. But which would be your second choice? If you could be either any of these four, archers or shooters or whatever they are, which would you rather be? Of course, you'd rather be D, but what would be next? I would suggest that your second choice is A. After choice D, I think your second choice should be A. And the reason is that this person has a very careful control over their technique. And it looks like their only problem is that they probably need to perhaps adjust the sight on their instrument. So whether it's a bow or a .22 rifle or whatever it is, they just need to adjust the sight probably. Or maybe some there's something that they're doing wrong every time. And if they can just correct that, that would bring them right into where they want to be. They have to shift their sights. For example, they might have to shift their sights down a little bit and a little bit to the left. If they do that, then they'll be right in the target, just like D, just like competitor D. Now this type of error right here that I've shown on this target, where you can correct it by maybe just adjusting your sights, or if we were doing an experiment, it might be by zeroing our balance, for example. This type of error is called systematic error. Systematic error can be corrected by an adjustment. It can be adjusted for. If you can recognize it, you can probably adjust for it. You can make an adjustment to the system to correct it. Like I said, calibration of an instrument, like zeroing your balance. Now the reason I picked A over B is because if you're person B, it definitely looks like person B is shooting for the bullseye, but they have some sort of random error going on. So this kind of error, where it's basically about the spread of your data, the spread of your measurements or your results, that is called random error. And this could be related to a number of things. For example, maybe they're breathing too heavily, or maybe they're nervous, so they're shaking, so it's shaking around. But in our case, in the laboratory, it is typically due to uncertainty in measurement. And remember, we're using this phrase in a very specific way. We mean the error that comes from the estimation process itself. It comes from that kind of estimation. Like, remember when we passed the graduated cylinders around the room, and a lot of people got a slightly different reading off of that. That's what we're talking about here. That is random error. And it is different than systematic error because it's not in the same direction every time. It's not the same magnitude every time. The error, the difference that's generated between your data points, it's not the same direction. It's not in the same direction or of the same magnitude every time. And it's not systematic. That's what that means. And it's much more difficult to correct for. because one thing you can do to try to get this down, so you can reduce it sometimes by practice, because practice might get you to be more consistent in the way that you estimate it, for example, or if you're shooting an arrow or whatever it is. You can reduce it by practice or by using a more precise instrument. So by changing tools. For example, maybe this person is on the rifle club and they're shooting with an old 22 that has a barrel that's all kind of scratched up inside and degraded, and so it's putting this kind of random factor, this random motion into the trajectory of the bullets. Or maybe they're using a really cheap bow that's just not well designed. So you can change your instrument. For example, taking a measurement, you might be using a really cheap balance that only measures to the nearest tenth. Well, if you get one that's much more high quality and more expensive, it might measure to the 10,000th of a gram. And by doing that, you're going to drastically reduce your random error. It could be as simple as switching from a 100 milliliter cylinder to a 10 milliliter graduated cylinder, as we saw in our little activity when we passed the vessels around. So you see the connection between the two. If somebody is precise but not accurate, then the problem is systematic error. If they are not precise but accurate, then the problem might be random error. And remember also, as I mentioned up here, that precision is actually precision is easier to get a grasp of, to quantify, than accuracy. Because a lot of times we don't really know the true value. We're just kind of estimating the true value to begin with. So that makes it makes accuracy a little bit more kind of elusive. Now, in a case like this, in shooter C here, they have both problems. They have high random and systematic error. All right, and this person has low error of both types. Now, when you're writing your lab reports and you're doing your uncertainty section and you're discussing your errors, this is the terminology that you should be using. And then what you can do is you can expand on each of these. Is there any systematic error in this experiment? And if there is, then how could it have been corrected for? And then in case of random error, what is the source of the random error? It is always going to include uncertainty in measurement. So your lab report should always include uncertainty in measurement, but it might include some other things as well. Like maybe there was a breeze and you noticed this breeze and it was blowing across and making the measurement fluctuate. Maybe it seemed to be that the balance itself was just fluctuating. Or maybe people were leaning on the table and causing it to shake. So there's a lot of reasons for this random error. Systematic error might include things like the samples being wet when you weighed them. And if that was consistently true, then your masses would all be a little bit high. Another thing you want to do in your uncertainty section is you want to try to quantify these errors. How large are they? And you've learned how to do that with uncertainty in measurement. You've learned to use the plus or minus notation to quantify that. In the case of systematic error, try to imagine or try to estimate how much is this in terms of a percentage of your total measurement. What do you think that error really is? So if you think that you might have been off because of the wet metal, for example, how large of an effect would that have been? Or if it was bubbles in your cylinder when you were measuring the volume of the metal, how large of an impact would that really have? Try to estimate that. That's going to be an important skill as we move through the year. All right, so I hope you understand more about accuracy, precision, random error, and systematic error and how they all fit together.